So in section 4.7, we've got figure 4.17, and this is found in a discussion of soil density. And there's two ways to look at how dense a soil is. One way is by defining a thing called particle density. The other way is by defining a thing called bulk density. Okay, so particle density, you can see in the definition in your book, is defined as the mass per unit volume of, keyword here, soil solids, as opposed to soil with the spaces in between, with pores in between, and that sort of things. So what we're trying to get at with soil particle density is a measurement of just the solid materials. Okay, so just the solid material. So that's what we're seeing here. Okay, so typically we say that soil in a typical situation is half pore space, which is composed of space or water-filled space, and half solids. Well, with particle density, we want to know what's the density of just the solid stuff. So basically, we're asking how dense is the rock, the mineral material that makes up this soil. We don't care about pore space and all that kind of stuff. We just care about what the rock density or the mineral density of that soil is. Okay, so that's one thing. And you can see in your book that we can actually assume that the particle density of any soil is 2.65 or so, okay, give or take. Because particle density is a little bit harder to get to than just plain old bulk density. So we can assume that it's 2.5, your book has it as megagrams per, meter per meter cubed. That also is the same reading as what we'll do in some of your lab exercises, which is 2.65 grams per centimeter cubed. Okay, think about that. 2.5 grams. So if we have a material, we have 2.5 grams, that's a weight, per a volume, per X amount of volume. In this case, it's 1 centimeter cubed of this material, one volume of centimeter cubed, is 2.65 grams. So we go ahead and in soil science we assume that most of soil carries this 2.65 grams per cubic centimeter particle density of the rock material, the mineral material that's in the soil. So that's particle density. As opposed to that is bulk density. And so your book says that's defined as the mass of a unit volume of dry soil. Okay, so it includes, that volume includes both solids and pores. Solids and pores. So you can see in this picture here that we've got a volume, okay, and in that volume we've got some pore space, we've got some mineral space, and so that's what we're thinking about, is that mineral space and the pore space together. So how dense is that material? And you can think about making this either more dense or less dense, right? So you would be able to compress this maybe a little bit more, and it would become more dense because you're pushing out the pore spaces. You're making the pore spaces that are in there smaller and smaller and smaller. So you could think about making, and that would make this more dense, so the number would actually go up, right? We would have a denser material, okay? So we'd have a denser weight per volume, okay? So this is in this instance, we're looking at the volume of 1 cubic meter. So this is a meter, this direction is a meter, this direction is a meter. The same thing goes when you see this grams per centimeter cubed, the reading is the same, okay, same number. So they're kind of interchangeable in that way. So with bulk density, we can change bulk density, okay? We can compress it, or maybe we can aerate it. You've seen an aerator maybe out on a turf field, or a lawn aerator. Those lawn aerators can change the bulk density, can make the soil less dense per volume of soil. So those are the differences between bulk density and particle density. You can see that we calculate bulk density. Okay, calculate bulk density by saying what is our weight of oven dry soil, so we dry it out and we weigh it, okay, divided by the volume of that soil. So the volume would be some height, width, and length, okay, just like we have in this picture. So we take the volume and we take the weight and we divide it by the volume of that soil. Okay, so that gives us these sorts of numbers: 1.33 megagrams per meters cubed, or 1.33 grams per cubic centimeters. We'll go through some calculations of this as well to help you kind of further understand this.